Hello, dear students. We are starting our first general chemistry experiment today. Before starting the experiment, we need to talk about some laboratory safety rules. We always have to be careful while working in the laboratory. It's very important for our own safety and the safety of others. Conduct yourself in a responsible manner at all times in the laboratory. Follow all written and verbal instructions carefully. If you don't understand a direction or part of a procedure, ask your teacher before proceeding with the activity. Never work alone in the laboratory. No student may work in the science classroom without the presence of the teacher. When first entering a science room, do not touch any equipment, chemicals, or other materials in the laboratory area until you are instructed to do so. Perform only those experiments authorized by your teacher. Carefully follow all instructions, both written and oral. Unauthorized experiments are not allowed. Do not eat food, drink beverages, or chew gum in the laboratory. Do not use laboratory glassware as containers for food or beverages. Observe good housekeeping practice. Work areas should be kept clean and tidy at all times. Let's look at most commonly used laboratory equipments. Beakers are used to hold and heat liquids, multi-purpose and essential in the lab. Erlenmeyer flasks are used to heat mix and store liquids. The advantage to the Erlenmeyer flask is that the bottom is wider than the top, so it will heat quicker because of the greater surface area. And we have graduated cylinder. Graduated cylinders are used to measure the volume of liquids. This is bread. It used in titrations to measure exactly how much liquid has been delivered. And then magnetic stirrer. Magnetic stirrer is used to stirring and heating liquids in beakers or flasks. Pipettes are used for moving small amounts of liquid from place to place. Test tubes are used for storing, mixing, and heating small amounts of chemicals. Volumetric flasks are used to measure one specific volume in mixing aqueous solutions. Pipette bulbs are used for accurately measuring and delivering small volumes of liquids, usually between 0.1 and 10 milliliters. And Bunsen burner is used for heating and exposing items to flame. So, experiment 1 is identification of a substance. Physical properties. Every substance has unique set of properties that allow us to differentiate it between them. These properties are physical and chemical properties. Examples of physical properties are color, odor, taste, density, solubility, melting point, boiling point, etc. For chemical properties, there are flammability, toxicity, acidity, reactivity, etc. In physical properties, there is no change to composition or identity of substance, but determination of chemical properties results in the change of the identity of the substance. Solubility. The solubility of a substance is usually expressed as the mass of a substance in gram. Depending on the molecular structure of a substance, it will have different solubility in different solvents, depending on the nature of the solvent. The other property is density. The density of a substance is defined as the mass per volume. It's a useful physical property in order to identify unknown substances. So, in this experiment, We will use three solvents: water, cyclohexane, and ethanol. We will use S for soluble, I for insoluble, and we will use SP for sparingly soluble. And we use extra liquid. We don't know this liquid, so this is unknown liquid. We will try to find this liquid with solubility test and density test from the appendix 1. This is appendix 1, physical properties of some common laboratory chemicals. Okay, let's look at water and ethanol. Water has used as solvent and ethanol as solute. We took about 2 milliliters of water and put into the tube. Then we add about 5 drops of ethanol. We shake the tube, then it is soluble. Water and cyclohexane. In the same way, water has used as solvent and cyclohexane has used as solute. So as you see, there is line in the liquid. There are two phases, so this is insoluble. Let's look at ethanol and water. This is soluble. We continue with ethanol and cyclohexane. Ethanol has used as solvent, cyclohexane has used as solute. We can say soluble and sparingly soluble, both correct. And cyclohexane and water. Yes, we have a line in this liquid, so this is insoluble. Cyclohexane and ethanol. Yes, we have cloudy appearance, so we can say sparingly soluble. Let's look at liquid unknown this time. Water as a solvent, unknown as solute. We have a line and two faces, so this is insoluble. Unknown liquid and ethanol. Yes, this is soluble. And we continue with unknown liquid and cyclohexane. The last one is unknown liquid and cyclohexane. So this is soluble. Okay. We have measured the weight of Erlenmeyer flasks. Weight of this Erlenmeyer flask is 23.5810 grams. And we took 10 milliliters from unknown liquid and we put into the Erlenmeyer flask. Okay, let's look 10 milliliters unknown liquids plus Erlenmeyer. Weight of 10 milliliters unknown liquid plus weight of Erlenmeyer is 30.2181 grams. So we know volume of liquid, we know weight of Erlenmeyer, and we know Erlenmeyer, weight of Erlenmeyer plus unknown liquid. So now you can find the liquid density easily, and you can find what the liquid is from appendix 1, this table, from this table. You can find easily. And so this is the end of the experiment. Thank you for listening. Please send your report sheet, including your conclusions and calculations, to my email address. This is my email address. Thank you.